Dear students, in this module we're going to look at MS1 and the intact protein mass measurements. Before I begin with the content, let me point out that if you are doing bottom-up proteomics, then I'm referring to a peptide, and if you're doing top-down proteomics, then we're referring to a protein. So here I mean intact molecular weight measurement of your precursor molecule, which may be a protein or peptide depending upon the protocol that you're using. Okay, so introducing the topic. So once you have ionized the protein or peptide, then it is ready for injection into the mass spectrometer chamber. So once you have it ionized and you inject it into the mass spectrometer chamber, then it will take a motion according to the charge and the mass. We call it the mass over charge ratio. Okay, so this mass over charge ratio can be measured by looking at the speed and the direction of motion of this intact molecule. Let me show you a schematic diagram of how MS1 works. So you take up the sample and you insert it into the mass spectrometer, wherein there is a very powerful magnet that has the ability to deflect masses of different sizes in a different way. So even if a protein has a very small difference in mass from some other protein, this powerful magnet can actually separate these two by giving them different trajectories of motion, as shown here in red. So once your molecules, they enter the magnetic field and are separated by the magnet, then you can measure their mass over charge ratios as shown here. The charge is assumed to be 1 in this case. Therefore, you can have a different mass over charge ratio for different masses. However, if the charge is different for a single protein, then the same protein can have different mass over charge ratios. So in order to simplify the problem, I am assuming that the charge is 1 on all the sample molecules. So once the mass over charge ratio is measured, there are collectors or detectors at the end of the mass spectrometer, and each mass over charge ratio is collected in Faraday's collectors and is output in terms of a numerical value. This numerical value can be used in any software, in any bioinformatics tool, or you can write your own tools to process these values and actually find out which proteins were there in the original sample. So this gives you an overview of how MS1 works. So just to briefly overview this diagram again, you just take a protein, you charge it, you insert it into the magnetic field. Magnetic field separates all the molecules by their mass over charge ratio, and you detect those mass over charge ratios, and you have MS1. Okay, so once you have the MS1 data, you need to process it. So this can help you arrive at the intact molecule's molecular weight. The problem that you must cater for is that the charge should be 1 for the same type of intact molecules. If the intact molecule of a type has multiple charge states, then you can have difficulty in arriving at the mass over charge ratio. Also, the mass select. So if you can select a mass range, then you can actually select that molecule only for onward analysis. So if you have different MS1 mass over charge ratios reported from the mass spectrometer, then by mass selecting a specific range from it, you can select those particles, those molecules for onward processing. So in conclusion, the MS1 spectra reports the intact protein or peptide molecular weight for you, and that this is very useful when you want to have a mass select of a specific sample molecule for onward analysis.